Refraction of light at plane surfaces. Refraction of light. The change in the direction of the path of light when it passes from one transparent medium to another transparent medium is called refraction. The refraction of light is essentially a surface phenomenon. It has been experimentally observed that when a ray of light travels from a rarer medium to a denser medium, say from air to glass, it bends towards the normal. That is, angle of refraction is less than angle of incidence. The deviation of the ray is I minus R. When a ray of light travels from a denser to a rarer medium, say from glass to air, it bends away from the normal. That is, angle of refraction is more than angle of incidence. The deviation of the ray here is R minus I. The ray of light incident normally on the surface, separating the two media, passes undeviated. That is, such a ray suffers no bending at the surface. If the angle of incidence angle I is 0 degree, then the angle of refraction angle R is 0 degree. The deviation of the ray is 0. Laws of refraction. The incident ray, refracted ray, and the normal at the point of incidence all lie in the same plane. The ratio of the sine of the angle of incidence, I, to the sine of the angle of refraction, R, is constant for a pair of a given media. That is, mathematically, sine I by sine R is equals to constant, or mu. The constant is called the refractive index of the second medium with respect to the first medium. Effect on speed, frequency, and wavelength due to refraction of light. When a ray of light gets refracted from a rarer to denser medium, the speed of light decreases, while if it is refracted from a denser to a rarer medium, the speed of light increases. The frequency f of light depends upon source of light, so it does not change on refraction. The speed of light v in a medium is related to its wavelength lambda in that medium, and the frequency f as v is equals to f lambda, or wavelength lambda is equals to v by f. Factors affecting the refractive index of a medium. Nature of the medium. Lesser the speed of light in a medium as compared to that in air, more is the refractive index of the medium. Mu is equals to c by v. Physical conditions such as temperature. With increase in temperature, the speed of light in the medium increases, so the refractive index of the medium decreases. The color or wavelength of light. The speed of light of all the colors is the same in air or vacuum, but in any other transparent medium, the speed of light is different for different colors. In a given medium, the speed of red light is maximum and that of violet light is least. Therefore, the refractive index of that medium is maximum for violet light and least for red light, that is, mu of violet is more than mu of red. The wavelength of visible light increases from violet to red, and so refractive index of a medium decreases with increase in wavelength. Principle of reversibility of the path of light. According to this principle, the path of a light ray is irreversible. Refraction of light through a rectangular glass block. Lateral displacement. The perpendicular distance between the path of emergent ray and the direction of incident ray is called lateral displacement. Factors affecting lateral displacement. Dependence on the thickness of medium. More the thickness of the medium, more is the lateral displacement. Dependence on the angle of incidence. More the angle of incidence, more is the lateral displacement. Dependence on the refractive index. More the refractive index of the medium, more is the lateral displacement. Since refractive index increases with the decrease in wavelength of light, so lateral displacement increases with the decrease in wavelength of light. That is, lateral displacement is more for violet light than for red light. Multiple images in a thick plain glass plate or thick mirror. The image A2 is the brightest image in the above because it is formed due to light suffering a strong first reflection at the silvered surface Pn. Prism. A prism is a transparent medium bounded by 5 plane surfaces with a rectangular cross section. Refraction of light through a glass prism. Here, I1 plus I2 is equals to angle of prism plus angle of deviation. Factors affecting the angle of deviation. The angle of deviation depends upon the following factors: the angle of incidence I, the material of prism, that is, on refractive index mu, the angle of prism A, the color or wavelength lambda of light used. The angle of deviation becomes minimum when the angle of incidence is equal to the angle of emergence, that is, when I1 is equals to I2 or when R1 is equals to R2. In the position of minimum deviation, the refracted ray inside the prism is parallel to its base if the prism is equilateral. Real and apparent depth. An object placed in a denser medium, when viewed from a rarer medium, appears to be at a depth lesser than its real depth. This is because of refraction of light. Apparent depth is equals to real depth upon mu of the medium with respect to air. This shift is equals to real depth into 1 minus 1 upon mu of the medium with respect to air. Apparent bending of stick under water. Above figure shows a stick or pencil obliquely placed in water. The portion OP of the stick under water, when seen from air, appears to be shortened and raised up to OP dash. This is due to refraction of light from water to air. Some consequences of refraction of light. A star appears twinkling in sky. A person's legs appear to be short when standing in a pool. Print on paper appears to be raised when glass slab is placed over it. A water tank appears shallow than its actual depth. Transmission of light from a denser medium, glass or water, to a rarer medium, air, at different angles of incidence. Case 1. When the angle of incidence is small, that is, I is less than C. The refracted ray is away. Case 2. When the angle of incidence is equals to the critical angle, that is, I is equals to C. This is a case of refraction along the plane. Case 3. When the angle of incidence is greater than the critical angle, that is, I is more than C. This is a case of total internal reflection. Critical angle. Critical angle is the angle of incidence in the denser medium corresponding to which the angle of refraction in the rarer medium is 90 degrees. Relationship between critical angle and refractive index. Mu is equals to 1 by sine C. Factors affecting the critical angle. First, dependence on the color of light. The critical angle increases with the increase in wavelength of light. Dependence of temperature. The critical angle increases with increase in temperature. Total internal reflection. When a ray of light is traveling in a denser medium, is incident at the surface of the rarer medium at an angle of incidence greater than the critical angle for the pair of media, the ray is totally reflected back in the denser medium. This phenomenon is known as total internal reflection. Essential conditions for total internal reflections. The light must travel from denser medium to a rarer medium. The angle of incidence must be greater than critical angle for the pair of media. Total internal reflection in a prism. To deviate the ray of light through 90 degrees, this action of prism is used by periscope. To deviate a ray of light through 180 degrees, this action of prism is used in binoculars and camera. To erect an uninverted image without deviation, this action of prism is used in a slide projector. The given image shows the total internal reflection through a prism where each angle is 60 degrees. The given image shows total internal reflection and refraction of light through a 30 degree, 90 degree, 60 degree prism or a right angled prism. Some consequences of total internal reflection. Phenomenon of mirage. An optical fiber used to transmit light signals. A piece of diamond sparkles when viewed from certain distance and directions. A crack in glass vessels often shines like a mirror. An empty test tube placed in water in a beaker with its mouth outside the water surface shines like a mirror when viewed from certain angles.